If you are studying for the KCNA exam, you absolutely need to understand containers. Because before Kubernetes can manage applications, those applications usually need to be packaged as containers. And if containers sound mysterious, don't worry. This is one of those topics that sounds more complicated than it really is. A container is basically a lightweight package that includes an application and the things it needs to run. Simple idea, big impact. So in this quick bite, we're breaking down what containers are, why they matter, how they are different from virtual machines, and what you need to remember for the KCNA exam. Welcome to QuickBytes Education. Today's quick bite is all about containers, explained simply, quickly, and clearly. Let's get started. A container is a lightweight, isolated environment used to run an application. It packages the application code together with the dependencies the application needs, such as libraries, runtime components, configuration files, and system tools. In plain English, a container helps answer this classic IT problem. It worked on my machine, so why is it broken everywhere else? Yeah, every IT person has heard that one before. Containers help solve this by packaging the application in a consistent way, so it can run more reliably across different environments. That could be a developer's laptop, a test server, an on-premises data center, or a cloud environment. For the KCNA exam, remember this. A container packages an application and its dependencies so the application can run consistently across environments. Now, this part is very important. A container image and a container are related, but they are not the same thing. A container image is like a blueprint or template. It contains the application, libraries, dependencies, and instructions needed to run the application. A container is the running instance of that image. Think of it like this. The image is the recipe. The container is the actual meal being served. Or, if you like IT examples, the image is the saved package, and the container is what runs from that package. For the exam, keep it simple. Image equals package template. Container equals running instance. Containers matter because modern applications need to be portable, consistent, and efficient. Before containers, teams often ran into environment problems. The developer had one version of a library. The test server had another version. Production had a different configuration. And suddenly, everyone is staring at logs at 2 o'clock in the morning, pretending they enjoy troubleshooting. Containers reduce that problem by bundling the application with what it needs. They also start quickly, use fewer resources than traditional virtual machines, and make it easier to scale applications. That is one reason containers became such a major part of cloud-native computing. Containers and virtual machines both provide isolation, but they work differently. A virtual machine includes a full guest operating system. That means each VM has its own operating system, kernel, libraries, and application. This gives strong separation, but it also uses more resources. A container does not include a full operating system. Instead, containers share the host operating system kernel while keeping application processes isolated from each other. That makes containers lighter and faster to start than virtual machines. Here's the simple comparison. Virtual machines virtualize hardware. Containers virtualize at the operating system level. For the KCNA exam, remember, VMs are heavier because they include a full operating system. Containers are lighter because they share the host OS kernel. Containers need a container runtime. A container runtime is the software responsible for running containers. Common examples include Containerd and CRI-O. Docker is also commonly used when people are learning containers, especially on local machines. But here is a key Kubernetes point. Kubernetes does not directly run containers by itself. Kubernetes works with a container runtime to run containers on worker nodes. So if someone asks, does Kubernetes replace the container runtime? Nope. Kubernetes orchestrates containers, but the runtime actually runs them. In Kubernetes, containers usually run inside pods. This is one of the biggest exam points. Kubernetes does not usually manage individual containers directly as the main unit. The smallest deployable unit in Kubernetes is the pod. A pod can contain one or more containers, but most beginner examples use one container per pod. So, the relationship looks like this. A container image is stored in a registry. Kubernetes creates a pod. The worker node uses a container runtime. The runtime pulls the image. Then the container starts inside the pod. That is the flow you want to understand for the KCNA exam. Let's say you have a simple web application. The application needs Node.js, some libraries, configuration files, and the application code. Without containers, you might have to manually install everything on each server. And if one server has the wrong version of Node.js, surprise, something breaks. With containers, you build an image that includes everything the application needs. Then you run containers from that image. In Kubernetes, you could create a deployment that tells Kubernetes, run 3 copies of this application. Kubernetes then runs pods, and those pods run containers based on the image. If one pod fails, Kubernetes can replace it. That is where containers and Kubernetes work together. Containers package the application. Kubernetes manages where and how those containers run. Containers are useful because they support portability, consistency, speed, and scalability. They make it easier to move applications between environments. They help teams deploy software more reliably. They start quickly compared to virtual machines. They work well with automation and CI/CD pipelines, and they are a major building block of cloud-native applications. Now let's clear up a few common misunderstandings. A container is not the same thing as a virtual machine. A container is not Kubernetes. A container is not automatically secure just because it is isolated. And a container should not be treated like a permanent server. That last one matters. Containers are often designed to be temporary and replaceable. In cloud-native environments, if a container fails, the better approach is usually to replace it instead of logging in and manually fixing it like an old-school server. That mindset is important for Kubernetes. A common mistake is confusing an image with a container. Remember, the image is the template, and the container is the running instance. Another mistake is thinking containers include a full operating system like virtual machines. They do not. Containers share the host OS kernel. Another mistake is thinking Docker and containers are the same thing. Docker is a popular platform for working with containers, but containers are the broader concept. And one more big one. Do not forget that Kubernetes runs containers inside pods. For KCNA questions, pod is usually the Kubernetes object you should think about first. For the KCNA exam, remember these key points. A container packages an application and its dependencies. A container image is the template used to create containers. A container is a running instance of an image. Containers are lightweight because they share the host operating system kernel. Containers are more portable and efficient than traditional virtual machines for many application workloads. A container runtime, such as Containerd or CRI-O, runs containers. Kubernetes orchestrates containers by running them inside pods, and containers are a foundation of cloud-native application delivery. So, what is a container? A container is a lightweight, isolated way to package and run an application with the dependencies it needs. Containers help applications run consistently across different environments. Images are templates. Containers are running instances. Virtual machines include full operating systems. Containers share the host OS kernel. And in Kubernetes, containers run inside pods. In one sentence, a container is a portable application package that makes modern cloud-native applications easier to run, move, scale, and manage. Like, subscribe, and keep building your knowledge with QuickBytes Education, one quick bite at a time.